Hi, pre-calculus. Let's go through this third page of the closure video. All right, I'm just getting situated here. All right, so 162 says consider the piecewise defined function. So what we should do here to graph the function, I already got one. I need to graph x squared, and I'm going to graph x cubed and 1. But I need to take a look at the stipulations that are given that domain. So the first one for the quadratic x squared, x must be less than -1. I'm still going to go ahead and plot -1 on, add it with my table. But I'm going to make sure at -1 it's an open circle because this says x is less than -1. So the value, if I plug -1 in, -1 squared, so if I plug x into the function, -1 squared is 1, -2 squared is 4, -3 squared is 9, so on and so forth. So let's go ahead and draw our graph. We'll start at -1, -1, 1, we'll make that open because we're not including that value. -2, 4, and -3, 9. And I'm just going to go ahead and draw that piece of the quadratic. X cubed, let's graph this. So for the cubic, it says go from -1, allow x to be from -1 to 1, including those values. So -1, 0, and 1. And we're going to make sure that we it's closed at these values. So -1 to the third power is still -1, 0 to the third power is 0, 1 to the third power is 1. So let's graph this. -1, -1, closed. 0, 0, 1, 1. And if you remember, it kind of wiggles through here. Okay, if you remember what that cubic function looks like. And finally, our table for the last value, or the f of x equals 1. Now this says x is greater than 1, so we're going to start at 1, 2, 3, 4. I could have honestly just done 3 values there. Open circle at 1, but every y value is going to be 1. So this will be a horizontal line. It would be an open circle at 1, 1, but we honestly already have it closed because of that cubic function. So we're just going to draw this. That horizontal line. Okay, so part B is y equals f of x continuous at x equals -1. At x equals 1, use the formal definition of continuity to justify your answers. So if you look on your assessment resource page, you kind of have those 3 parts that we have to take a look at, and we have to satisfy each part of that formal definition of continuity in order for us to say yes, f is continuous at that value. So let's start with looking at the coordinate point. Like if I think of f of -1, what is the value of f of -1? And the value is -1. The next part is to think of the limit of f of x as x approaches -1. Okay, so if we're looking at -1, we could say that this limit does not exist. And the reason for that is because the limit of f of x as x approaches -1 from the right. Okay, so if I look at the limit of f of x as x approaches 1 from the right, from this right side, I'm approaching -1. Well, that does not equal the limit of f of x as x approaches -1 from the left, because if I'm coming from the left approaching -1, I'm approaching the value of 1. So the limit of f of x as x approaches -1 does not exist. Therefore, we can say that f is not continuous at x equals -1. What about at 1? X equals 1. F of 1, the value, if the input is 1, the output is 1. The limit of f of x as x approaches 1 equals 1. Okay. since, or because, therefore, if f of 1 equals the limit as f of x as x approaches 1. So those two values, step 1 and step 2, those values were the same. So because f of 1 is equal to the limit of f of x as x approaches 1, we can say that f is, in fact, continuous at x equals 1. Next question. Determine the slope of the tangent. We're going to do the instantaneous rate of change to the curve f of x equals negative 5x squared plus 10 at x equals 9. So if you remember this, we previously we found the average rate of change. So we would do, we're going to take the function and we're going to input 9 plus h minus, take the function and input 9, and then divide that whole thing. It ends up just being h in the denominator. Now, what makes this instantaneous, if you remember our discussions about this h value, okay, so the limit as h approaches 0, or as those two, if you think of the secant line, as those two values got closer and closer and closer to each other, and instead became a tangent line, we were finding the limit as h approaches 0. So what we're supposed to do here is go ahead and input, here's our function, we're going to input 9 plus h into the function first, okay? So that means we have the limit as h approaches 0, and inputting into that function f of x, we take negative 5 and we multiply it by the quantity of 9 plus h squared plus 10. Now I'm going to be really careful here because I'm going to subtract, and I was whenever I taught this, you have to put parentheses after it so that we're careful about our signs. So now I'm going to input negative 5, 9 squared, and then plus 10. Now, oh, sorry, all over h. You're going to do all this work to go ahead and take, this here, take 9 plus h multiplied by 9 plus h if you want to make a box. Follow order of operations here to get 81, multiply that by negative 5, and then add 10. Your next step, what you should be able to get to is this. We should be able to say that we can get to negative 90h minus 5h squared, all divided by h. If you did not get to that step, you need to go back and make sure you multiplied with the box correctly, you distributed negative 5. Over on this side, you made sure to get negative 5 multiplied by 81, and then plus 10. Okay. From here, we can see that both terms we can divide both terms by that h in the denominator. So the limit of h of 0, limit as h approaches 0 of negative 90 minus 5h. Well, that means that we're evaluating as the limit of this function as h approaches 0. So we're going to go ahead and plug 0 in for h. So negative 90 minus 5 multiplied by 0. The answer is negative 90. Question 165. Let vector v equal negative 6, negative 1, and vector w equal 8, negative 9. Find the magnitude here. So what we're going to end up doing is we're going to take v, okay, and we're going to multiply that vector by 3. We're going to write it out like this. And then we're going to take vector w and multiply by that 7. So now I end up with the vector here is negative 18, negative 3 in component form, and I'm going to subtract 56 and then negative 63. Now I showed this also that we could take this negative 7 and go ahead and think of multiplying by negative 7. Either way really works to get you to your resultant vector here. So negative 18 minus 56 is negative 74. Negative 3 minus a negative 63 is actually 60. So here is component form. That's not our answer. I really shouldn't have circled that. We are going to go ahead and find the magnitude of this. So we're going to take the square root of negative 74 squared and add, square root, sorry, 60 squared. So that value equals 95.27. Go ahead and find the direction of this resultant vector. So we're going to do 6, and we've got vector W, so 8, negative 9. We're going to add 2 multiplied by this vector. Sorry, I'm running out of space here. So that gives us 48 and negative 54 plus negative 12, negative 2, written in component form. We're going to add these two together, which gives us the resultant vector of 36, negative 56. Remember, you have to think in terms of where is this vector located? So if we went right 36 and down 56, we're going to be somewhere in this fourth quadrant, which means our final result, we have to add 360 degrees to that. So we're going to take theta, or theta equals, we're going to take inverse tangent, negative 56 divided by 36. All of this comes from your formula sheet as well. Make sure your calculator is in degree mode. So we end up with negative 57.26. We're going to add 360 degrees to that because we're in the fourth quadrant. Remember, first quadrant, you would just keep angle as is. Second quadrant, you're going to add 180. Third quadrant, add 180. Fourth quadrant, add 360. So theta equals 302.74 degrees.